Having a mesh network leads to a lower cost of communication because the same information can flow through multiple pathways. So the resiliency that you get in terms of the information that travels across the network is much better through a multipath network instead of a point-to-point communication.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. Today we are diving into the realm of wireless mesh networks, the invisible threads that seamlessly connect the devices in our IoT ecosystem. They are resilient, robust, and expand automatically as more devices are added. So they do play a pivotal role in shaping our connected world. I am delighted to have Chetan Joshi, lead product manager at Panasonic Industry Europe, on the show, and he will share with us some insights on how these networks work, what challenges they have, and maybe what the future holds to this piece of the IoT puzzle. Welcome, Chetan. It's really great to have you on the show. How are you?
Thanks a lot, Ruth. I'm very pleased to be here. I'm a regular listener, so I couldn't be more happier to be with you today.
Great. Before we start, can you maybe introduce yourself and tell us what you do at Panasonic?
Absolutely. So I've spent nearly 7 years at Panasonic Industry Europe now. At Panasonic, we have the luxury of, as a company, doing many, many things. But at the end of the day, the goal is to be a contributor to the betterment of society. We do that in many different ways by the means of our products, by the means of our technologies, trying to make the best products and technologies for our customers. In fact, I'm actually very proud to be talking to you here as a Panasonic member, because we have now initiated a carbon net impact program that's called Panasonic Green Impact. It has a goal of reducing up to 300 million tons of carbon dioxide emissions by 2050. And in near term, by 2030, our goal would be to just be a net zero company in our own systems. So to be a part of such a company is actually quite awesome, I would say. And one of the most important things in context of the topic that we are going to discuss today is that mesh technologies form a critical part of the puzzle because of the way how they contribute in the next industry 4.0 in order to bring down carbon dioxide emissions.
For our listeners who are not as deep in the topic as you are, can you explain a little bit the concept of mesh networks?
Yeah, absolutely. So when we say mesh networks, let me start by saying that we are actually talking about wireless mesh networks today. You can eventually think about a wired mesh network as well. But in 2023, the idea is to go wireless in order to save costs. And if you just take a step back, and not just a single step back, if you go back 130 years, when wireless communications started out, right? So there was the father of wireless communications is a guy called Jagdish Chandra Bose. And when in 1894, he first demoed the first wireless communication, he just basically rang a electric bell from across the hall.
Yeah. Wow.
That made newspapers headlines all across the world, right? Cut to 130 years later, when my daughter, who's barely 17 months old, right? So when she's not able to see a wireless bulb working, she looks at me funny, and that's the progress that we have made with wireless communications in last these many years. Why do I say this? Because when you think about the kind of complexity that needs to be hidden inside wireless communication between 2 points from a point-to-point communication, that is already complex enough. But now just imagine how this complexity compounds itself when there are tens, hundreds, thousands, tens of thousands different nodes that need to be part of a singular network and have to share data streams where information goes from one point to the other in a format of many to many communication. So this is something that is today being addressed via different sort of mesh technologies. There's no one size fits all for mesh communication. You have different implementations that you use different sort of PHY level technologies such as Wi-Fi, such as Bluetooth, such as Threads, such as Zigbee, and many, many proprietary implementations over such technologies, right?
Why are wireless mesh networks so essential for the Internet of Things?
When we think about Internet of Things, you would think about things that are your everyday objects. But the real scale at which the things need to be connected is actually in the industry, in the brownfield projects where there is existing infrastructure that has already been deployed and it needs to be updated, it needs to be made smart. And in such cases, trying to lay out wiring is not something that you would find feasible, neither in terms of the manpower that it requires, nor in terms of the total capital cost expenditure. This is where having a wireless front end that automatically lays out and deploys an autonomous mesh that is self-healing, self-repairing in nature, leads to very high efficiencies in terms of getting the work done.
And what other benefits are there? You said it's cheaper and it's more resilient, meaning one device disconnects, it will be rerouted to a different device, right? That's how it works. Are there any other benefits?
I mean, the benefits at the end of the day are the costs that you save. So when you have, speaking from an information theory point of view, having a mesh network leads to a lower cost of communication because the same information can flow through multiple pathways. So the resiliency that you get in terms of the information that travels across the network is much better through a multipath network instead of a point-to-point communication. So that is the biggest advantage to start with. Eventually, as you go down deeper into the applications of the mesh network, the advantages come in form of, let's say, application-specific benefits that you can derive out of a particular technology. So, for example, a Bluetooth-based mesh would be an excellent choice for something that you would deploy in commercial lighting kind of situations. A Wi-Fi mesh, on the other hand, with heightened complexity is excellent for extending the range of your already high data throughput network, but which doesn't contain as many nodes. So it's really delving down into the depth of the individual technology that you would understand what the benefits are.
Oh, okay. So yeah, let's go into that. You already mentioned commercial lighting versus extending the reception of your wireless in your smart home, I suppose, or in your home in general. Would you like to focus more on Bluetooth mesh first, and we can discuss what other use cases there are?
Yeah, absolutely. So the thing that's really good about Bluetooth is that it has penetrated the human consciousness much like Wi-Fi. So it's something that you immediately identify of. What happened was that when Bluetooth started out, they were just doing point-to-point connection or one-to-many connections in form of broadcast messages. But eventually in 2017, they released a new specification that in and of itself is a standalone specification, not part of the main Bluetooth as you know it. It's called Bluetooth Mesh. This allows some implementation of a mesh that is very unique in the sense of how it creates and how messages propagate. So typically when you think about messages going across a network, you would think that they are being routed across through a routing table or something like this, like in traditional networks. What Bluetooth Mesh does is that it manages a very intuitive managed flooding approach, where much like a flood, the message eventually propagates throughout the entire network. And by carefully choosing the parameters within the Bluetooth mesh, you are able to have a very, very decent performance of where messages bounce across multiple nodes and reach to the end device. And the applications thereof are very evident in high density mesh networks, such as commercial lighting, something that you would see in hypermarkets or on office floors, where you have sometimes hundreds, and many times thousands of nodes that need to be controlled in a synchronized manner. The scale of Bluetooth mesh somehow allows it to reach even up to multiple thousands. As I said, the biggest network that I'm personally aware of has somewhere just under 5,000 nodes in a single network.
Oh, wow.
So that's quite awesome.
So that means when you say controllers, I can, in the case of lightning, check if all the lights are working, if they're on and if they're off. Is there any other kind of information that is transported?
So lighting is a very curious industry. I mean, once you start thinking about lighting, you think, okay, I just need to flick the light bulb on or off, right? But once you're introduced to the different kind of things that are going in the lighting industry in terms of ambient lighting, in terms of mood, in terms of setting scenes, there have been many different companies that have sprung around in the sector who are leveraging the mesh technologies. I can probably cite the example of Kasambi. It's a very well-known brand in the lighting space, who have actually created an ecosystem of lighting fixtures and lighting drivers and whatnot. And you just need to plug and play and be introduced to the world of awesome ambient lighting. Just to finish on the last point, you could imagine the kind of savings that you would get out of automating a complete building's lighting infrastructure. So with a single smartphone or same simple application, you're able to control a multi-level, multi-floor setup. Similarly, and that leads to very high gains in terms of the carbon savings. Similarly, if you think about solar industry, I mean, the way the deployment needs to happen of this technology is something that's non-trivial in nature. So the solar industry today faces many challenges in terms of land acquisition, in terms of having the right kind of solar panels available, etc. But at the end of it, it's all about how to optimize the interaction of the solar panels with the sun itself.
Okay.
And for that, what happens is that imagine a solar farm. There are many different panels laid in rows and columns and what have you. These need to be tilted so that during the course of the day, they receive optimal sunlight, right? Now, one way to do is to lay out wiring for everything, right? That is certainly not ideal. The other way to do it would be to lay out a wireless mesh network to control that. And a lot of vendors use Zigbee as a protocol in order to deploy something at small to medium scale, because this is where the size of networks today is on solar farms. You would have typically 100 to 200 solar trackers. Now, if you were to scale that to a bigger operation, this is where things start to become really interesting, because the bigger solar parks now have 10,000 or 20,000 solar panels in wide swaths of land, which goes from, let's say, a kilometer square kind of land area. In such cases, the amount of nodes that would be going into a single mesh network increase the complexity of the deployment. And it's certainly something that you would have to think twice about when using any mesh network, because when you start deploying, for example, let's take Zigbee as an example here, right? So a Zigbee needs multiple coordinators, right? And you would expect that if I have enough coordinators inside thing, they'll be taking care of their own nodes, their own end devices, and I'll have, let's say, more or less functional mesh. But since this is routing table based and these are simple microcontrollers, at some point of time, they find their limitations and the network performance goes down. So this already shows you, Ruth, that there is some complexity to a mesh when you start scaling it within an application segment. So for that, if you were to switch to a proprietary mesh that I can cite here, for example, Wirepass, these guys, they have a proprietary solution that also runs on 2.4 gigs and sub gigs and now on 1.9 gig as well. It allows you to have a really performing, highly scalable mesh solution that can be deployed in very dense, or let's say very sparse networks, depending on what sort of low-level file you're using. So you can think about covering something like a personal area network to a wide area or city-wide area network based on the mesh technology that you might be using.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. What other challenges are there? You just mentioned the complexity once you try to scale from a smart home to a big solar park. What other challenges are there to make wireless mesh network work properly?
So when you say work properly, it has to be heard in the context of what the end application is.
Okay.
Right?
Yeah.
So if today your end application requires high latency communication because you're okay with a sensor that is reporting a passing wild animal in a bridge, or something like that.
Okay.
That's a low latency communication, or let's say it's just tracking animals through the means of mesh network, and you should be fine, right? But if you take the same technology and then deploy it to a network that requires millisecond level of latency, so quite low latency networks, then you would think twice about what you are going for. Right. Similarly, other challenges might be about the actual throughput, the network throughput that you want to achieve out of the whole mesh. When information propagates from one end across multiple nodes, what's the total throughput that you would require? And in that, you would think about the different kind of topologies that you might adopt based on the technology that you're using, the kind of support infrastructure that you might want to deploy alongside your mesh solution. For example, a gateway, routers, or something like that. So a reconfigurable or a configurable solution, depending on which technology you move ahead with. And all of these challenges put together, if you have a decent set of technologies at your disposal, you can eventually come up with a solution or solutions that work for one case or the other.
When you mentioned applications that require a very low latency, what would be a good example for this?
A typical example of this could be, EV charging.
Okay.
Right. So EV charging stations, I mean, it's a trend that has just picked up like crazy. So, first of all, it started with residential charging and, let's say industrial charges, 2 per parking lot, 3 per parking lot. And then now what you see is that every supermarket has a dedicated parking lot with only chargers deployed everywhere. Right. So while there are, let's say, some time sensitive notions that typically would not be well addressed by, any sort of wireless networking, for that you would eventually go to a more reliable solution such as Ethernet itself.
Okay.
There are many use cases that may be well suited for wireless mesh networks. The trend that we see today in the market is that many different vendors of EV chargers are integrating Zigbee in their solutions, as well as Wi-Fi.
Okay.
This typically could be for exchanging usage data, load balancing, or all the different kind of informations that might be shared between two chargers.
Will the new standard matter in this case at some point?
Yes, so Matter is a very curious thing, because Matter is something that runs at an application level, and what it does is that it creates like a unified language for all of the smart objects to talk to each other, right? So as of today, you can think of Matter as being, as it starts out in our time, it's starting out making the everyday objects at home compatible with each other. In the context of a smart home, if you have an electric car, it's essentially a smart computer with wheels on it, right? So I anticipate, and all of us anticipate, that very soon your EV chargers and your smart cars will also be appearing on your home network, and you could control them with your smart Google Home or Alexa or whatever not. So there are underlying protocols such as Wi-Fi or Thread, which is yet another form of mesh network, mesh networking standard, that form the basis for Matter, right? So if your EV charger needs to be identified on a smart home network, having these underlying technologies such as Wi-Fi or Thread are actually quite important.
But if I understand you correctly, Meta at this point is more of like a smart home use case and not in an industrial IoT landscape?
So the guys at Connectivity Standard Alliance, they have done a brilliant job. So what they have focused on is right now how to make the fundamentals of having an ecosystem of products that talk to each other, how to get that part right. Right. So this would require a lot of details about digital identity, on how to introduce a certain node in the network. What are the different layers that could be used in the communication stack? As I said, Wi-Fi and thread. What's a good end node with, let's say, sleepy behavior, which doesn't consume a lot of battery power? What's on the other end, something that's acting as like the central aggregator of information, such as a gateway or something. They have done that part right. And since the technology has been drafted the right way, it's only a matter of time that this eventually finds more industrial use cases as well.
In your opinion, what other advances or improvements in wireless mesh technology might we see in the future?
I think mesh is not a new technology to start with, right? So it has been around for a very long time. What we see in the market right now is that there is adoption across various parts of the frequency spectrum. Historically, solutions such as Zigbee mesh were already available in sub-gigahertz spectrum. This is something that's very, very interesting for very low throughput communications, for simple control applications such as switch or something like that. But eventually, once you have these mesh networks deployed at relatively high density and they are in a decent environment, you would see a requirement of everything that is in context of a smart home or smart industry gradually climbing up to the 2.4 gigahertz ISM band. There are a lot of solutions out there already, some of them already cited, because this allows you to package a lot of, let's say, not just the control information, but a lot of information on the data payload itself. So you can send a lot of sensory information across the network, and that would lead to higher distributed intelligence use cases.
And I think the last topic that comes to mind we haven't touched yet is security. Is that an issue?
That's a very good question, Ruth. And I think it's important to say that security in 2023 and on will be the cornerstone of IoT. So based on everything that we are seeing today in terms of governments releasing regulations, you would require, in order to get your CE approval in Europe, for example, you need to have the Cyber Resilience Act that requires you to have certain level of security guarantees on your end IoT product. We've also heard recently from FCC that they're talking about, in context of raising user awareness about security, something like a 5-point energy rating system that they have on appliances. They want to do something similar for the security as well. And I think it is fair to say that all of these mesh technologies have baked some part of the security into them, from the link level security to the application package that you would, for example, deploy in case of a firmware update over mesh. All of that can be encrypted in terms of the data package itself. In terms of how you provision these devices, if you take the example of Matter application that you said over thread or over Wi-Fi, you need to have these PKI infrastructures put in place. You need to have the root certificates that need to be issued by some certified product attestation authority and all of these things. So as a general trend, I would say that if we just only talk about the technologies, the security is baked into the link level already, right? So you would base on them. And security, as you would know, is not like there's no single point of failure that can be tolerated in the system. So Bluetooth or Wi-Fi links would bring their level of securities on the thing. Then you would add on top of that encryption on the application level and so on.
Right. And if our listeners are now trying to decide whether wireless mesh networking is a good solution for them or their infrastructure, and how they might want to get started with integrating them into their projects, what would your advice be?
In general, right? The first thing from planning out an application is to really understand what's the end goal of your infrastructure, right? once you have identified the key differentiator that you want to deploy, you would have to go along the lines of identifying the right technology that is suited for your own application.
Mm-hmm.
And you only do that once you start thinking about the end application, right? Secondly, irrespective of which technology that you choose, I'm a hardware guy, right? So I would have to speak about the hardware
Mm-hmm.
itself. You would have to really focus on a very, very, very good, robust RF design. Because whatever you do, no matter how fancy your software, mesh is all about pumping information through carefully designed nodes that all form part of a single network. Right? And network is nothing but, let's say, carefully tuned frequencies and sharing that frequency in the best manner possible, right? So if your RF design isn't good enough, if you're not able to design a radio that is centered at the intended frequency of communication, then you would never derive the fruits that these technologies promise.
Is there anything I have not asked you that you were missing? Something that you would like to talk about?
I think that we have had a very good discussion. Eventually, I think we'll have to reconvene in 2 years' time, Ruth, I would say, to see how this very fast-moving space has changed, which are the new application areas that have taken up. We already see a lot of, let's say, smart metering applications, asset monitoring, asset tracking, pipeline industry, and forests that are getting these technologies in terms of, let's say, preventing from wildfire and stuff like that. Let us give each other 2 years time frame and then reconvene. Then we can really talk about how the market has moved.
Lovely. I would say it's a date. So talk to you again in 2 years, hopefully in between that as well. It was really fascinating and interesting. Thank you so much for your time, Chetan, and have a great rest of the day.
Thanks a lot, Ruth. It was absolutely fantastic talking to you.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.